Okay, growing up. So this one was fun. Um, this was, we do different tech for good initiatives where we explore areas that, we think technology will just bring value to society and will help, uh, many different people in many different ways. And this one in particular that we did recently was for the Global Climate Change Summit. We wanted to have something to showcase there as well. Um, and we got together with a group called Intelligent Growth Solutions. And what they do is they design systems for vertical farms. And these are indoor, human-controlled environments that we can customize as we see fit in order to, as efficiently as possible, grow crops. I thought this was fun growing up because, this is growing up, the quantum ecosystem is growing up, and we're growing up kind of together, and there's a lot of synergies that I think efficiency-wise we can bring to the space of controlled agriculture. And so just some facts about greenhouse emissions and waste in food production that happens around the globe. What we found here was looking at the requests that the farm was asked to produce and trying to match that production with demand is often very challenging because you're dealing with essentially delayed information in the market. Some event could happen, there could be a food shortage, and then people need food immediately. Or you're producing at regular levels, and for some reason, there isn't demand for your product because usually you would estimate it, but maybe seasons change or something happens, the weather predictions change, and so that it's not needed. So what can you possibly do as a grower to adapt to demand that, if it takes you it takes you weeks to grow your product and then another week to ship it, how are you ever going to meet demand in real time? And so it's a huge, complicated problem. One thing that we found was that in these highly controlled agriculture solutions, there are things that you can do. You can't speed up growth necessarily. You're always trying to grow as quickly as you can, but you can slow growth down. And what this approach did is we used, one of these quantum methods in order to, based on the demand requirements, to show which crops to slow down the growth of in order to reduce waste and still meet demand, and then and help help address that problem of waste. And so what this does is it basically looks at the plan, looks at the crops that are growing, what the schedule they're on, and it gives you recommendations for, okay, you can, deprive this particular plant of light for this duration, and it will decrease its fertilization or decrease its production, and you can time it better for a demand schedule that you're trying to meet. So this was an interesting project in trying to reduce waste and make the world a better place. Another one that we did in the same vein was we looked at kidney exchange networks. And so this is when you need a kidney and you have someone who is willing to give you a kidney, but they're not a match. And so you would enter a network of people who are in the same scenario where you're trying to find someone who you can, get a kidney from and someone else can give their kidney to, and finding the maximum number of people who can be a part of that exchange so that the maximum number of people can get kidneys was another optimization problem we tackled as one of these Tech for Good initiatives, which was really interesting. All right,